All right, I want to talk about Taylor and Maclaurin series today. So this represents the Taylor series. So if a function f has derivatives of all orders at x equals c, c is a number, some kind of constant, then the series, this one, you can express as f of c plus f prime of c x minus c over 1 factorial plus f double prime c x minus c squared over 2 factorial and so on. And this is the formula. So I'm sure you see the pattern. Now, we call it the Taylor series for f of x, a function f of x. Now, if c equals to 0, then the series is called the Maclaurin series of f. So, and this is what it looks like. So this is Taylor. And now the Maclaurin would look pretty much the same, but the c in this case is 0. So it looks actually simple. So the series, now instead of c I'm going to put 0, and instead of x minus c factor I'm going to put just x, and it's not f of c, it's f of 0 plus f prime of 0. Now it's just x over 1 factorial plus f double prime of 0x squared over 2 factorial. We did talk about this in class. And so on. So f of nth degree of the derivative of 0, x to the n, or n factorial, and so on. Now, I did show you how to derive the sign of x and express it as the Maclaurin series when x equals to 0. But I think we also did the natural logarithm of x, but I'm not sure. So actually, today I want to do a few and maybe repeat the sign of x again, just in case you forgot. So I'm going to start with a new page. So let's say my function is f of x equals to sine of x. And by the way, I did tell you in class that you have to memorize a few functions: sine of x, cosine, tangent, and I'm going to actually post a list of the functions that you have to memorize on Haiku. Now, f of 0, so remember we're trying to express the sine of x as Maclaurin series. If x is 0, sine of 0 is 0. The first derivative of, you know what, let me just actually do it on the other side. So the formula, I just want to put the formula again. F of 0 plus f prime of 0, x over 1 factorial, second derivative, x squared over 2 factorial, and so on. So in our case, we deal with signs, so f of 0 means sine of 0, and that's 0. F prime of 0, you know what, let me just do f prime of x, which is sine of x prime, and that's cosine, and cosine of 0 is 1. So I'm just going to actually, as I actually find each one, I'm just going to plug it into my formula. So f of 0 is 0, plus f prime of 0 is 1, so it's 1 times x over 1 factorial. Next, second derivative, that would be derivative of this, is negative sine of x. Plug in 0, and we get 0. So that means this is 0 plus triple derivative. So we're talking about this guy. So that would be negative derivative of sine is cosine, but we have the negative sign. And negative cosine of 0 is negative 1. So that would be negative now, not positive. Let me just make it cleaner. Negative x cubed over 3 factorial. Next, we're just going to do a few more and that's it. So derivative of negative cosine. Cosine prime is negative sine, so but we have a negative, so that becomes just sine of x. At 0, sine of 0 is 0. So we have plus 0x to the 4th over 4 factorial. I'm sure you see the pattern. We're going to do one more, and that's it. That will be enough. Derivative of sine is cosine. At 0, you get 1. So it's plus, now 1, x to the 5th over 5 factorial, and so on. So let's see. So we get sine of x equals x over, well, I don't want to put x over 1 factorial. I'm just going to put x. That's gone, minus x cubed over 3 factorial, that's gone, plus x, I'm sorry, that's 5, x to the 5th over 5 factorial. So you can see it alternates, so the next sign would be negative, right? And you notice that these guys are odd exponents, so obviously the next one is going to be x to the 7th over 7 factorial, then it's going to be plus, and so on. Now, we can tell by the ratio test that this series converges for all values of x. So let's actually do so. So let's do it. We say that f of x, you know what, I'm going to use a brand new page. F of x equals sine of x equals, and we got the series starting at 1, infinity, and if you remember it alternates, so we're going to put negative 1 to the power of n plus 1, and look at this pattern, 3 exponents, 3, 5, 7, so all odds. So that would be x to the power of 2n minus 1 over, and same for n to 2n minus 1 factorial. So this is your general form, this is your series that represents sine. Now we want to perform, we call it the ratio test, to see what, just to find the radius of convergence or interval of convergence. So the ratio test says we do limit as n approaches infinity, don't forget absolute value, negative 1 to the power of, add 1 to each n, so that would be n plus 1 plus 1, so that becomes n plus 2. X to the power of 2n plus 1 minus 1 over 2n plus 1 minus 1 factorial, divided or multiplied by the reciprocal, 2n minus 1 factorial over negative 1 to the power of n plus 1, just copy it. And we get limit as n approaches infinity. Now if you look at these guys, it's the division, so you subtract your exponents, right? So it's the same as negative 1 to the power of n plus 2 minus n plus 1, right? You're subtracting your exponents. So you get negative 1 to the power of n plus 2 minus n minus 1. So that becomes negative 1 to the power of 1, which is negative 1, right? And the negative doesn't really matter because it's absolute value, so we can just forget about the stuff that I circled. Now I'm going to pause for a second so that I can just do my work, and then if needed I will just comment. All right, so here's what I did. I distributed the 2, so I got 2n plus 2 minus 1, and it's right here. And then I did the same thing right here, distributed the 2, so I got 2n plus 2 minus 1, and that's here. And I put them together, so, and simplified, so 2 plus, minus 1 is 1, so it's 2n plus 1. And I'm sure you understand what happened here, so it's just 2n plus 1 factorial. So this is what we get right here. Now we need to continue, see what we can get at the end. So I can express it, the top one, as x to the power of 2n times x times 2n minus 1 factorial over 2n plus 1 factorial times x to the power of 2n minus, it says minus 1. So you know what? Let me just do this for a second. So you can cross out these guys. Now since it's negative 1, your exponent, so you can move it up, right? And make it positive, the exponent. So this is the same as x to the first in the numerator. But you already have x on the top. So that becomes, what? You get x times x, which is x squared. So we get x squared times 2n minus 1 factorial over, now 2n plus 1 factorial. How do we simplify that? It's 2n plus 1 times 2n times 2n minus 1 and so on, right? So can I just put 2n minus 1 factorial? So that means I get, what do I have left? 2n plus 1 times 2n. Let me just copy it. 2n minus 1 factorial. And you noticed we can get rid of these guys. So we end up with limit as n approaches infinity. X squared on the top, and on the bottom it's just 4n squared. I don't have to do this. 4n squared, I can just leave it the way it is. Now as n approaches infinity, let me just rewrite it. It's 1 over 4n squared plus 2n times x squared. So as n approaches infinity, this thing approaches 0. 0 times x squared is 0. And now do you remember, when you do the ratio test, and then at the end you get 0, what happens? Then you say the series converges for all values of x. Now, this is how you prove it, but at some point you have to memorize it. You have to remember. So when it comes to sine, your Maclaurin series looks like this, and you have to remember that this series converges for all values of x. You don't want to derive it over and over again. Now I want to show you another example. Now it's actually the AP style question. It says f of x equals sine of x cubed. It says find the Maclaurin series for this function. This is, I mean, you don't want to derive it again because that's going to take forever. But what you can do, you can just start with your, and that's why I said you have to memorize. So you remember, we derived it just a few minutes ago. We say the sine of x, Maclaurin series. What does it look like? X minus x cubed over 3 factorial plus x to the 5th 5 factorial plus, and so on. Now, we can conclude that f of x actually equals to some kind of new function, g, and instead of x, you simply replace x with x cubed. And this is the one I'm talking about. So that means we're not talking about sine of x anymore. We're talking about sine of x cubed. So that's why I call it a new function. It's not sine of x, which is f. Now it's a sine of x cubed, and I call it g of x cubed. Okay. Now we just said that the Maclaurin series for sine equals to that. Now what's a sine of x cubed? You simply replace each x with x cubed. So you get, now instead of this x, we're going to put x cubed. Minus, instead of x, this x, we're going to put x cubed. But you have another cube outside, right? Sitting right here. So you're basically replacing x with x cubed, but you keep your exponents. Whatever your function is, you keep it the same. It's just each x you replace with x cubed. 3 factorial plus x cubed to the power of 5 over 5 factorial and so on. Now let's simplify a little bit. We get x cubed minus x to the 9th over 3 factorial plus x to the 15th over 5 factorial minus 9, 15, so the next one would be 21 over, and that's 7 factorial, and so on. See how helpful it is when you actually remember by heart what your basic sine of x looks like. So then you don't have to derive again. And when you have a function that looks more complicated, just like sine of x cubed in our case, that would take a long time. So if you memorize it, then that's it. It doesn't really take that much time to express sine of x cubed. Find the Maclaurin series for a sine of x cubed. Now remember, I told you there are certain functions that you have to remember. So for sine, we just said, we just went over it. Now for cosine, you can derive it again. Do exactly the same thing we did in the beginning, but I'm not going to do it now. So I'm just going to tell you that it's going to also alternates. Now instead of odd numbers, you're going to have odd, even exponents and even factorials. Kind of easy to remember, and so on. And you notice there's a pattern, so we can express it as negative 1 to the power of n, x to the power of 2n over 2n factorial, because we get even exponents and factorials. And by the way, this function, this series also converges for all real numbers. Okay. Now there's another one that you have to memorize, or you can always derive it. It's 1 over x, and it's 1 minus x minus 1 plus x minus 1 minus x minus 1 cubed to the 4th. Also alternates, so it's negative 1 to the power of n, always x minus 1 to the power of n. The other one that you have to memorize, and by the way, interval of convergence for this one is it's different. It's from, and again, everything you can prove. So from 0 to 2. So far we have sine, we have cosine, we have 1 over x. Another one, very helpful if you remember, if you learn this by heart. It's 1 minus x plus x squared, or very easy to remember, plus x cubed, plus x to the 4th. Also alternates, so it's negative 1 to the n, and it's just x to the n. Okay, and this series converges for x between negative 1 and 1. And again, you can prove it. The next one is ln. of x, natural logarithm of x, also you have to memorize, or again, if you can't remember, so you can always derive it. It's x minus 1, and then it's x minus 1 squared over 2 plus x minus 1 cubed over 3 minus x minus 1 to the 4th over 4 plus alternates minus 1 to the n over n. And this one, this series converges between x and 2, and by the way, including the 2. And the last one that you have to memorize, is tangent inverse. And it's x minus x cubed over 3 plus x to the 5th over 5, no factorials, over 7, and that would be negative 1 to the nth, x to the power of odd, right? 2n plus 1 over 2n plus 1. And this series converges for all the x values between negative 1 and 1, including the negative 1 and 1. Very good example. Next, it says find the power series for f of x equals cosine square root of square root of 2x. Okay, so power series. You have to start with the basic cosine of x. And as I said, you have to memorize it. So it's 1 minus, it alternates and evens. So x to the 2nd over 2 factorial, x to the 4th over 4 factorial minus. Okay, now, it's in our case, it's not x. It's square root of 2x. So you replace each x with square root of 2x and see what happens. So then you say cosine of square root of 2x equals 1 minus square root of 2x but squared plus square root of 2x but to the power of 4 minus square root of 2x to the power of 6 and so on. So now let's simplify. We get 1 minus, it's just 2x over 2 factorial plus, that would be square root of 2x squared is 2x, but it's to the 4th power, so it's like 2x times itself, so it's 4x squared. Am I right? I think so. And minus, and now it's 6 power, so that would be another 2x. So you multiply, you get 8x cubed over 6 factorial. So that's it. Done. See how helpful it is when you actually remember how to write your cosine of x as a power series. Next example would be e to the x. By the way, that's another one that you have to memorize. Oh, I don't have space here, so I would put e to the x. And this one is also easy actually to derive, but let's do it here. So it says find the power series for e to the power of x squared. So you have to memorize that e to the x equals to 1 plus x squared over 2 factorial plus x cubed over 3 factorial, always plus to the 4th, 4 factorial, and so on. Why? Let me derive it quickly. E to the 0 is 1. So that's why you start with 1. Then you take the derivative. E to the x prime is e to the x. Plug in 0, you get 1. So that's why your exponent here is it's invisible 1, and then times x. Next, derivative of e to the x is, so we're looking for second derivative. It's still e to the x. Plug in 0, you get 1. So that's why your coefficient here is 1 again. And then it's just, you put x squared over 2 factorial next to it. Okay, and so on. So every time you take your derivative of e to the x, you still get e to the x. That's why your coefficients are the same. Each coefficient equals to 1. So this is what you have to memorize. Now, we're looking for e to the x squared. So each x you simply replace with x squared. So you say e to the power of x squared can be written as 1 plus, instead of x I'm going to put x squared, I don't need parentheses, plus x squared but squared over 2 factorial plus x squared to the third, 3 factorial, x squared to the fourth, 4 factorial, and so on. So simplify, you get 1 plus x squared plus x to the fourth plus x to the 6th plus x to the 8th, and so on. So done. Not that hard. Next example is a little bit different. It says, use a power series to approximate this integral. Actually, you know what? I'm gonna, yeah, let's do this first. Okay. It says, use a power series to approximate this integral with an error. So let me just put that, with an error less than 0.01, and calculate that error. All right, so what we're going to do is this. We're going to start with e to the x first. We're talking about that function e to the x, and we remember, I hope, this is one of those basic functions. The power series looks like this. Sorry. Now, e to the power of negative x squared is going to look like that. 1 minus what? Instead of x, we're going to put negative x squared, so it's negative x squared. It's like plus, but negative x squared. So that's why we put 1 minus x squared plus, now negative x squared over 2 factorial, negative x squared cubed over 3 factorial, negative x squared to the fourth over 4 factorial. Simplify, we get 1 minus x squared plus x to the fourth over 2 factorial plus, you know what, since we're going to integrate, so I don't want to use factorial, I'm actually going to find each, the denominator, evaluate 2 factorial is 2 plus x squared but cubed, so then it's going to be negative. It's going to be negative because of cubed, so it's going to be negative x to the 6, and 3 factorial equals to 6, 1 times 2 times 3, plus, since your exponent is 4, even, so we get x to the 8th over 4 factorial equals to 24, and that's going to be minus, and it alternates. Now let's integrate, because it says we need to integrate this. So it's integral of 1 minus x squared plus x to the fourth over 2 minus x to the 6 over 6 dx. So integral of 1 is x minus integral of x squared is x cubed over 3. Integral of x to the fourth over 2 is x to the fifth over 5, but you have the 2 on the bottom, so it's 10. Minus x to the 6 becomes x to the 7th over 7, but you have the 6 on the bottom, so that becomes 42. and so on. And that's from 0 to 1. So if you plug in 1, so what I did, I used my calculator, and I tried the first 4 terms, and I got 0.7428571429. Now, but if you actually use your calculator to find that integral, you get a 0.7468241328. Now, that's the true answer. So if you subtract to see the difference, to see what the error is, you get 0.0039669. So which is approximately 0.0, sorry, 0.003, well, let's say 4, which is, this error is less than 0.01, and that's what they want. And if you use more than 4 terms or less, your error is not going to be less than 0.01. So that's why I used the 4 terms. So that's about it. The homework is not going to be just on Maclaurin and Taylor series. Your homework is going to be just a regular, practice test questions, AP questions. But you're going to see a Maclaurin and Taylor series, among those questions. So please refer to this video and try those by yourself, okay? Try to do those questions by yourselves. And if you can't, then just ask me.